Greetings from the Lunar and Planetary Laboratory at the University of Arizona. My name is Dolores Hill. I'm here today to demonstrate two hands-on activities for you. One, you can try at home. It's called our mystery box. It's a lot of fun. The other one is a demonstration of the OSIRIS-REx asteroid sample mission's tag SAM collector, touch and go sample acquisition mechanism. All right, so let's begin with our mystery box. We've put together a mystery box that helps illustrate how scientists understand the world around us. All we can do is ask as many questions as we can and try to understand the answers. Sometimes we don't have all of the instruments we need to figure out those answers. Sometimes we need a better telescope or microscope or analytical instrument. Sometimes we can't even see the object that we're trying to understand, but we do our best. So this box illustrates how we can obtain some information about an object or a process or a question, but perhaps not all of the information that we would like, but we still do our best. All right, so I have a box with a slit in the top, and it's important not to peek. Okay, so I'm going to put my hand into the box and hold on to one object. And then we'll ask some questions about that object and see if we can figure out what it is or what it might be. So first of all, is this object heavy or light? Well, it's not heavy or light. It seems kind of reasonable. What shape is it? I don't know. It's irregular. It has some sort of a wire on it, I think. Some sort of a wire sticking out of it. Is it smooth or rough? It's smooth. What kind of material is it made out of? It feels like metal to me. How about what color is it? That's the trick question. There's no way we can figure out what color it is by just touching the object. That's a case where we would need a better instrument, our eyes, to see it. What is it made out of? Again, this is a bit of a guess. It feels like it's made out of metal, but I don't know for sure until I can see it with a special camera or a spectrometer that will analyze the material. Have I felt anything like this before? Maybe, I'm not sure. Okay, so do I want to make an educated guess on what this object might be? Well, sure. It feels like something metal, maybe some sort of a paper clip or something. Okay, so now we'll lift the lid. We'll pretend that we have a better instrument, a better microscope or telescope, a better spacecraft that's able to fly by our object and see what this is. Okay, so sure enough, we have a clip. And there's no way I could know for sure what color it was, right? Because I didn't have the ability to see it. I have a few other things in here that are kind of fun. I have several rubber duckies. One has a mustache and a beard. One has long eyelashes and stripes on its wing. And one is plain. There's no way you could tell one from another just from feeling, but you might be able to guess the duck. I have some ping pong balls. One is all black. One is half black, half white. One has spots on it. Again, you might guess that it's a ping pong ball, but you wouldn't be able to know what the surface looked like. I have an actual real rock. We have pencil, magic marker, eraser, one that's pink, one that's yellow. So you get the idea. You can use household objects for fun. Nothing dangerous, nothing gooey, right? We have an astronaut, space shuttle, all kinds of things. Okay, so now I'm going to shake it up and we'll try another one. All right, I have something. So, is it heavy or light? It's somewhat light. What shape is it? It feels cylindrical, but it has some facets, flat facets to the surface. Okay, what color is it? I have no idea. What is it made out of? I'm not sure. When I tap it, it feels like it could be wood, but it's not clear. There might be a rubbery material at the end. Okay, so have I held anything like this before? I think I have. I'm going to make an educated guess that this might be a pencil. Let's find out. Oh, sure enough, it's a pencil with stars on it. It could have been just a standard yellow pencil, but mine has stars on it. Okay, let's try one more, and you'll get the idea how you can do this with your family and friends. Okay, so now I'm holding something. Is it heavy or light? It's somewhat light. What shape is it? It seems to change shape as I touch it. It feels a little squishy. Is it rough or smooth? It's smooth, but it seems to have some little whiskers on it somewhere. This is unusual. What shape is it? This is irregular. I don't know what shape I would say it is. All right. What color is it? I don't know. The surface is somewhat smooth. Okay. Have I held anything like this before? Possibly. All right. Do I want to make another educated guess? Well, it feels like a dog toy or something to me. Let's find out. Oh, it's my little squirrel that lights up. It is squishy. You can see it's smooth. It has little whiskers on its tail. And there you go. So we use this box to illustrate how when we obtain better instruments, more instruments, or we can fly by an object very close, that we can actually learn more about it. And that's why we had to send the OSIRIS-REx spacecraft to Asteroid Benning to get up close to see what it looked like to determine where we were going to collect our sample. Because from Earth, this asteroid just looks like a point of light. Asteroids are rocky objects, most of them in space, and most of them orbit the sun between Mars and Jupiter. Some of them are near-Earth asteroids, like the one we selected. And that brings their orbits close to the Earth. So here's what Asteroid Benning looks like in shape. It's actually 500 meters or 1,500 feet across. It's considered small in the asteroid world. The asteroid the OSIRIS-REx spacecraft visited is as black as a piece of charcoal. And that's why we have black material in this case. We're going to demonstrate how the TAG-SAM, or touch and go sample acquisition mechanism, collected its sample. First of all, our plan was to collect 60 grams of material, or 2 ounces, and that's about the size of a Snickers bar. Here's what that would look like if it's big chunky material. Fine grained material fills this tube. We didn't know whether we would collect a mixture of both materials. We now know that we collected a lot of material, and it is indeed a mixture. So our science team made very, very careful observations over the entire surface of Asteroid Bennu to determine the perfect spot to collect our sample. We needed material that was very small particles, fine-grained material with not very many big rocks, so that we could blow gas through the dirt and collect it, trap it. So I'm going to show you how we did that without landing on the asteroid. We touched the surface for 5 seconds. The head of our mission likes to call that doing a high five, but it was a very, very slow high five. Okay. So here we have something that's very similar to our tag SAM collector. It's actually a chick feeder that we've cut a circle out of the bottom so that we can actually collect some sample. All right, so we're going to blow our gas for 5 seconds. Help me count. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. Okay, and then we very slowly, carefully back away from the asteroid. And eventually, this tag SAM collector is put away in the sample return capsule. We close the lid, and the entire spacecraft comes back towards Earth, and that capsule is ejected so that it lands in Utah in the year 2023. Then it'll be taken to NASA's Johnson Space Center, where they'll open it up in a very special clean room. And this is what they'll look for. They'll look for any material in that mesh and retrieve it. Every particle is precious. Then they'll look in the collector and see what they collected. So here's an example. We got a lot of material, There's a professor here at the Lunar and Planetary Lab who can take an object much smaller than that one and get 523,000 samples out of it. Okay, so let's try another test. We'll make sure our collector is empty. The Lockheed Martin engineering team that developed this tag SAM did more than 800 tests of their model, looking for different conditions to make sure that it could do its job under all of those conditions. So what if there's a small rock that we happen to touch upon? Will we still collect some sample? What do you think? Will we collect more sample or less sample? Let's find out. So help me count once more. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. That's it. Okay. So we did collect some material in the mesh that was respectable. And in our tag SAM collector, we collected a good amount of material. But in this case, it wasn't quite as much as the first time in an unobstructed area. Okay, what happens if we were to touch on a large rock like that one? There's our collector. And here we go. We'll count once more. What do you think? 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. That would be a bad situation. There's almost nothing in the mesh. And only a few grains in the collector. So that is why our science team was very, very careful to select the perfect site that had the least amount of rocks and the most amount of fine-grained material. On October 20th of 2020, just a few months ago, our spacecraft collected a huge amount of sample. It turns out that the real sample is more like these Rice Krispies that are flat and flaky, and light, and break apart when they hit each other. Cornflakes is another material that is very similar to the real asteroid, believe it or not. Our asteroid is made out of rocky material, but its shape and strength is very weak. All right, so if this is our collector, we touch the surface and blow our gas again for 5 seconds. What do you think we'll see? Let's find out. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. Wow. Did you see all that material that was distributed high into the surface? That's exactly what happened in our real collection attempt. Our cameras were seeing clouds of dust and particles that were getting lofted above the surface of the asteroid. There's no air on the asteroid, but they were ejected off of it momentarily. So let's see what we collected. All right, so there is material inside the mesh, which is wonderful. That's what it's designed to do, is to collect fine-grained material. And then inside our collector, we got a huge amount, very good amount of flaky, fine-grained material as well. We learned that some of these particles, when they hit each other while we're collecting our sample and stirring up that dirt, break apart. And it also turns out that we did touch a rock as we were coming into the surface very gently. And that rock was so weak that it fell apart. So we learned a lot about the surface strength of our asteroid during our process. The sample then is now safely inside the tag SAM collector that has been put away carefully into the sample return capsule. That capsule will eventually land at the Utah Test and Training Range, and we'll be waiting for it, and we'll be analyzing those materials here at the University of Arizona. So stay tuned. Thank you very much.